Hi guys, so in this lecture we'll be continuing on our chair form of cyclohexane, and we'll be comparing the stability that uh, at which position we should attach our bulky group, whether at axial or at equatorial position, and which after attaching the substituent either at axial or at equatorial, which uh, compound is more stable than the other. So the basic question is, where should we attach our most bulky group? Okay, so we have this question in mind, that which conformer of methyl cyclohexane is more stable. Okay, now if you draw the structure of the cyclohexane, it would be either we can attach it here or we can attach it here. Okay, so which is more stable, either the first one or the second one? Okay, so if we draw the Newman projection of both of the compounds, then we would get something like, for the first one I would get, let's actually number the carbon atoms for more clarity. So suppose this is 1, 2, 3, 4, 5 and 6. Similarly we should on the same basis I will be numbering in the Newman projection as well. Okay, so this is the first carbon atom, so here we have the second, and it goes to let us complete this. It has 2 hydrogen here. Okay, now the back carbon should be named as this would be the 5th one, and it goes something like here. We have CS3 attached here. 5th carbon goes to the 6th carbon, which has CS3 and H. Oh sorry, CS3 would be at the equatorial position. So 5th, CS3 would be at equatorial position and H would be at axial position. So this is the 5th carbon, this is the 6th carbon, and when I say this is the 2nd carbon, so this should be the first carbon. Okay, so we have at 1st carbon H here and H here. So 1st carbon, then 2nd, then this comes the 3rd. On 3rd carbon we have H at equatorial and axial, and now at the back this is the 4th, and at the 4th we have H here and H here. Okay, so this is the Newman for the first compound, and for the second compound we would have something like okay, so this is the first carbon atom. Now from the first it goes to the second carbon atom, and it comes as the 3rd carbon atom. We have the same naming convention here also. So 1, 2, 3, 4, 5 and 6. Okay, so at the first we have at the first carbon we have CS3 as here, and then we have H here, then a ring over here. So behind the first carbon we will have 6th carbon, and in 6th carbon we will have H over here and H in equatorial as well. Okay, then comes the 2nd carbon. Then comes the third carbon. At the third carbon we have H at equatorial and axial. Then comes the fourth carbon behind it. So at fourth carbon I have one fifth carbon which goes to the sixth carbon atom, which is in the ring. And at the fourth carbon atom we will have H at axial and at lower equatorial. So in this case I have okay, so I did something wrong here. I should be comparing it on the same carbon, the axial and equatorial at the same carbon. Okay, so substitute on this carbon atom only. So I should be making this as H rather, and this as CH3. Okay, so let me reiterate over what I just did. Okay, so the question was which conformer of methyl cyclohexane is more stable, either this or the second one. So I made the Newman projection of both the compounds. For the first carbon, for the first compound, this is the first carbon atom. For the first carbon atom we had H as here and here. So for the first carbon atom, H is one at equatorial, another at axial. From one it goes to second carbon atom. Second carbon atom we have again 2H, one at axial and another at lower equatorial. We need not make it here. Then it comes to the third carbon atom. At third we have equatorial. This is the third hydrogen, which is equatorial, and one is axial. So this is one H axial over here. Then it goes to the fourth carbon atom, which is the ring behind the third carbon atom. One hydrogen at axial and the other is at equatorial. So one hydrogen at axial and the other is at equatorial. From the fourth it goes to fifth carbon atom. So this is the fifth and this is the fifth. From fifth it goes to the sixth carbon atom, which is behind one in a ring. So at sixth we have at axial CS3 and at equatorial, lower equatorial, hydrogen, which is this hydrogen. Okay, and in the second Newman projection we have the first carbon atom. So H is at equatorial, upper equatorial, and H is at lower axial. So in this case one axial, upper axial, and one H lower equatorial. From one it goes to the second. So from one it goes to the second, and on second we have two hydrogen. So at two hydrogen would be at one at axial. Oh, I'm sorry, one at upper axial and one would be at lower equatorial. And on this carbon atom we would have from second it will be reaching third carbon atom. At third we will have upper hydrogen equatorial and one hydrogen lower axial, just like this. And from third it goes to the back fourth carbon. At fourth carbon we will have one upper axial, this is the one, and lower equatorial. So this is the lower equatorial. From fourth it goes to fifth. We have one carbon atom here and two hydrogen here. It would be axial, upper axial and lower equatorial here. And from fifth it goes to the sixth, which is behind first carbon atom, or in a ring we have showed it. So axial would be CS3 and upper would be H. Okay, so this is the Newman projection of the two compounds. Now if you want to compare which is more stable, then you can see that the bulky groups are adjacent to each other in this case, while in this case the bulky groups are opposite to each other. So this is more of a, you can say, Gaussian form, and this is a staggered form. And we have compared the stability of staggered, Gaussian, the fully eclipsed and partially eclipsed, and the order is staggered is more stable than the Gaussian form. Hence equatorial position for the substituent is more stable than axial position. So let me write it down formally, that equatorial is more stable than axial position, because equatorial is staggered. staggered. Okay, so always please remember this as a rule of thumb, important, that more bulky group will occupy equatorial position in a cyclohexane ring which is in chair form. Okay, so more bulky group will occupy equatorial position and obviously cyclohexane, chain form of cyclohexane. So let's compare the stability of the following cyclohexane rings with substituents. So question is compare stability. Okay, so we have compounds like, first is at axial, at equatorial we have this, and at axial we have this. Second is at axial we have this, at equatorial we have this. Third is at axial we have this, at axial again we have this, and fourth is obviously both at one at axial and another at equatorial. So what would be the order of stability? Obviously more bulky group should be at equatorial. So in these two cases, 3 and 4 would be at the last priority. Out of 1 and 2 we should compare that if both the bulky groups are at axial, then it's wonderful for us. So 2 is more stable than 1, so these two are compared. So for now between 3 and 4, as at least one of the bulky group or least bulky group is at axial or equatorial. So at least one of the substituent it is at equatorial, so 4 will be more stable than 3, hence just may rewrite it, 4 will be more stable than 3. In turn they would be less stable than 2 and 1. So this would be the correct answer. Okay, so in the next lecture we'll be seeing the flipping of chair form of cyclohexane, and we'll compare their energy in the next lecture. So till then, good luck and goodbye.